Loading. Perfect.
Yeah, we're live now, okay?
Good morning, everyone. Just give one more minute for people coming in. We're gonna start at 10:05, okay? Okay, welcome everybody. I hope you're having a great morning today. We're gathered here because today we're gonna be participating in the clustering activity, which we call BlueFeed's cluster webinar. So this is a webinar about innovation for a resilient aquaculture sector, and we hope this is a learning experience for all of you. So just so you know, the BlueFeed Cluster is a collaborative alliance bringing together 6 of the Horizon Europe projects, NeoGiant, Polypufa, SwitchFlock, Act Fast, Microbiomes for Soy, and EUAqua.org. So all of these projects are working toward a healthier and more resilient and environmentally responsible aquaculture and feed sector in Europe. And this is something that we're going to be learning today. So the objectives of this BlueFeed cluster. So for this cluster, we want participating initiatives to combine expertise in natural antimicrobials, sustainable omega-3 sources, advances bioflux system, climate resilient aquaculture strategies, and microbiome-driven sustainability solutions and organic fish breeding. So for the first objective, we want to promote cross-project collaboration to integrate knowledge from diverse research areas such as feed innovation, microbiomes, organic breeding, climate resilience, bioflux systems, and natural antimicrobials. Objective number 2 is to support the transition toward a sustainable aquaculture by providing practical, science-based solutions that improve the animal health, feed efficiency, and environmental performance. The third objective of this cluster is to foster innovation and technology transfer, connecting research outputs with industry needs, and also accelerating the adoption of new practices. And the fourth and final objective is to strengthen Europe's aquaculture sector, contributing to food security, circularity, and environmentally responsible production systems. Okay, so now these are the partners that are participating in this cluster. We have NeoGiant. We also have SwitchFlock, Act Fast, EUAqua.org, Microbiomes for Soy, and also Polypufa. Each of them are going to be doing a presentation based on their project. So that's what we're going to be doing right now. So the first project is NeoGiant. And for NeoGiant, we have Francisco Javier Alarcón, who's going to be representing the project. Please, Javier, go ahead.
Okay, thank you, Fernando, for letting me to present to show you a brief presentation of the project. Can you move to the next slide, please? Okay, well, good morning, everyone, all the presenters and the rest of people connected in this webinar. I'm speaking on behalf of the NeoGiant project coordinator, who is Marta Lores. Marta is a professor at the University of Santiago Compostela in Spain, who is unable to attend today due to another commitment at this same time. In her place, I will present a general overview of the project, a couple of the slides about the particular application of the project in the aquafeeds. The NeoGiant project is based in the reuse of Albarino graped mud as a source of polyphenol. As you know, Albariño is a specific grade from Galicia here in Spain. As most of you know, polyphenol as natural substances with relevant antioxidant and antimicrobial bioactivities. Grade mark is an abundant binary byproduct that contains a significant amount of different types of polyphenols. The project proposed to develop a simple, low-cost, low energy consumption procedure for obtaining a multi-component, ready-to-use extract as a green solution for obtaining functional ingredients and products using a sustainable approach for creating new value chains between the agricultural and livestock sector. Next slide, please. Fernando, can you move to the next slide? Okay, perfect. The main objective of the project is to develop and validate an innovative natural formulation to be used in cattle, in swine, in poultry, and also in fish production, but considering a holistic approach in animal production that include the whole cycle. That means the feeding, the animal health, and the reproduction of the animal, with the aim of reducing the use of synthetic antibiotics for promoting a reduction in the antimicrobial resistance in this animal. Next slide. The Neogiant products are based in three pillars fundamental. First one is the use of local biomass sources. In this case, we will use in the project the grade mark extract from the Albariño way to grade. The second one is to use cost-effective, efficient, and sustainable production method for a zero waste. That means to convert a waste in a business opportunity. The third pillar is to obtaining functional ingredients in a sustainable circular economy production system. Next slide. As I mentioned before, the Nayayan project developed both ingredients and also final products for livestock and agricultural species, focusing on three different sectors: the functional feeds, the use of plant-based treatment products for animal health to minimize the use of antibiotics, and the third one is the use of semen extender for animal reproduction. Next slide. The Neogiant Consortium is composed by industrial partners, by research institutions and universities for 8 European countries, and also a non-profit organization from Latin America. This is the CONACYT from Argentina. The project is coordinated by the University of Santiago de Compostela from Spain. The research organization and the companies have worked together in the following aspects: the production and evaluation of functional ingredients, the design of functional products, and finally, the validation of these products at pre-industrial scale as a previous step to move forward the large-scale production. Next slide, please. In particular, focusing on the application of this product in aquafeed, one of the aspects we evaluated was the fortification of feed with the grade mark extract and the development of analytical method for detecting the market component of the Albariño grade mark extract, and also to quantify this kind of component within the aquafeed. The stability of this compound during the feed extrusion process and also during the storage of the aquafeed is also evaluated. For example, in the graph, you can see the content of this bioactive compound in different feed supplemented with the Nioyayan product. And the graph showed the typical polyphenols that we use as market of the Albarino grape extract, and we can detect this kind of compound in the aquafeeds. Next slide, please. The feed supplemented, the feed I mentioned before, supplemented with the Nioyayan products, have been tested in different species, but under laboratory conditions and also at pre-commercial scale by the project partner that included the University of Porto, the Universidad de Santiago de Compostela, and also the company participating in a consortium. The target species were sea bream, sea bass, rainbow trout, turbot, salmon, amberjack, and also in the project it uses the zebrafish as animal model. In these trials, different aquafeed were formulated with the grade extract, and the flow technical and also the chemical parameters were evaluated. Among other parameters, the muscle chemical composition, also the intestinal microbiota, the resistance against pathogen challenge, the immune system, also the toxicity of the great magistral was tested against zebrafish. And there are 2 points relevant or 2 targets function of great interest regarding the use of the functional ingredient. Is the gut functionality, both as a physical barrier and also the role as assorted surface for the nutrient absorption. And also the oxidative status of the animal was tested. Among others, the purposes of those analyses was to answer the following question that may help to design new feeding strategies in aquaculture. In relation to the type of the ingredient used in the formulation of the diet, particularly when high level of plant protein is used, the question is if the functional ingredient can reverse the adverse effect that the diet with a high proportion of terrestrial plant protein produced in an animal. In relation to the time of the administration of this functional compound through dietary administration, the question is, does the feeding pills with functional fish have a long-term effect on fish? Other than those regarding with the use of the functional feed in emerging species or carnivorous species, if the use of this kind of functional aquafeed can allow to use higher level of plant protein ingredient in strictly carnivorous species, for example, as the case of the amberjack, Seriola dumerili. The feeding assay try to answer this kind of question for a real scenario using the Nioyayan product for the fortification of commercial diet in aquaculture. Next slide, please. From my side, this is all for provide a general overview of the project. If the audience want to know more information about the Nioyayan project, they can check the following channel where the more information is available. Thanks for your attention.
Thank you very much, Francisco Javier. That was a great presentation. I was gonna say, guys, if any of you have any question, please write them down in the chat, and we will try to answer all of them at the end of the presentations. Okay, so when we end up with the slides, we will have a space for answering questions. So just leave them there, and we'll be happy to answer all of them. So for the next speaker, we have Project Switch Flock, and we have I think it's David Sanchez who's gonna be speaking on
Yeah.
behalf of the project. So please, David, the floor is yours.
Thank you very much for the introduction, Fernando. Okay, I'm David Sánchez. I'm from UPV, Universidad Politécnica de Valencia, and I am the coordinator of the European Project Swiss Flock. That is a doctoral network from the Marie Curie Actions, belong to Horizon Europe program. You can move on, please. Which is based on bioflow technology. I don't know if you all have experience with this technology, but if you don't have, bioflow is like a organic macro aggregate where R attached is like working like a bioball. So like in biofilter, that is R attached microorganisms such as the diatomeans, bacteria, protozoa, and sometimes even we can find the invertebrates like nematodes. The next slide, please. But mainly the composition of this, the microbial community that is composed mainly by bacteria, particularly by heterotrophic bacteria that you can press. Sorry, I thought what I was doing, so I have some animations. So if you press the button, yeah, so the heterotrophic bacteria, so will be the responsible to assimilate mainly the ammonia. Next, chemiotrophic bacteria, as you know, is the typical nitrifying bacteria. So will be the responsible to assimilate both ammonia and nitrate. And next, microalgae and algae, but depends of the light exposition, we will have more proportion or less of this autotrophic species. We will have with ammonia, nitrate, and also phosphate that I thought I included in the new version. Anyway, can you press, please? All this ecological community, what it is doing is to help to maintain the water quality in the tank, okay, assimilating this excretion for the marine animals, but also it depends on the species, obviously, but also can be a natural protein source from these marine species. Therefore, can you press? It's a perfect example of the circular economy. The next slide. So this natural food that is present in the biofloc will allow us to reduce the, I guess it's our version, okay, anyway, fish meal inclusion and the feed intake. But we will, so therefore, we will improve the productivity and sustainability of the system. Next. Like the bioflow has its own bacteria community, we have a natural prebiotic, probiotic, and postbiotic compounds on bacteria that we will decrease the frequency of the pathogen events that could happens in aquaculture system. The next. That therefore we will allow or we will lead a better animal welfare. Next. One of the features of this technology is that if it works well, we have zero water renewal that obviously we will provide, well, we will decrease, next, the water requirements of the system, and next, and also improve the biosecurity. Thus, the tanks are not communicating like in RAS, so are individual. So if you have any pathogen event or any disease in one of the tanks, if you maintain the biosecurity protocols between when you with the proof or with the nets or whatever, should be not spread to the other tanks. So therefore, next, we can provide a 0-kilometer product with a lower carbon footprint and high food quality. Next, another of the advantage of this technology is it can be combined with another sustainable aquaculture system like integrated multi-trophic system or aquaponia. Next. Esa. That. Okay. The next, please. This. Okay. This is an international consortium, and we have is divided or is constituted by one part from the academic sector that will be composed by six research centers and universities from Universidad de Oporto, Università degli Studi di Padova and Palermo, University of Tromsø, Alfred Wegener Institute is a long name in German, and Universidad Politécnica de Valencia that acts as coordinator. The next. Also, we have the involvement of the participation of the industry, Kabelov with the economical assessment, Naturabella with as feed producer, and Lisaka as shrimp producer using biofuel technology. Next. Also, we have associate partners in the case of Universidad Federal do Rio Grande from Brazil as a specialist on biofuel technology, Dama Aquaculture from industry collaborating in the training events for the shrimp production, and also a spin-off New Food that will be a specialist in the food technology that we collaborate in to develop a new food, the food technology for biofuel products. Next. Okay, the project obviously is divided in different work packages related to the scientific work package. The first of them will be focused on sustainable aquaculture. And we have different PhD projects because it's a doctoral network. One of them will focus on the nutritional management of the biofuel technology. Another with the diet manufacturing, that is especially in this for special condition of the system. So the physicochemical conditions are slightly different. And also we will evaluate the application of this technology in combination with integrated multi-trophic system and aquaponia. The next work package will focus on animal welfare, that particularly we will evaluate to assess the effect of the microbiome in these different systems on intestinal health, and also like it's different that we are used to work on a RAS system or open waters. So we need to develop strategies to have a better control of the possible disease that can appear, that obviously we expect lower appearance, but it can happen. The next. Finally, like this technology has been applied mostly in other continents like South America or Asia. We want to assess if it's possible its implantation in Europe. For that, we need to do economic and environmental impact. Firstly, the economic assessment we will perform mainly by Kabelov as a specialist in this topic, and Università Politécnica Valencia, but mainly Università degli Studi di Palermo will be assessed the environmental impact and also the improvement we will how affect the improvements we hope to achieve during the project, if we can decrease even more the carbon footprint. And finally, like It is a new technology, and we want to assess and to compare with the traditional products from aquaculture if the quality is as we expected. So it's better, or even at least the same level, but we would like better. So the food quality, and also to develop food technology around the biofuel products. Next. Like it's a doctoral work, obviously we need we pay attention, special attention to the training work package, because it's the doctoral candidates are the main focus of our project, and we will include the virtual training workshops, on-site training days, and keynote lectures. That we will focus all of them in scientific topics, transfer skills, and we will promote the contact with the industrial sector. And the next, the previous one, yeah. And finally, now only to notice you that in the project is composed by 11 research projects, 8 in academic entities and 3 in the industrial sector, and is the period for the submission. So if you are interested, or you know somebody who will be interested, can access to the URL that is noted in the slide, and can take a look to the news and events that is in the website that is relatively open, and to take a look of the different PhD project that is proposed. So thank you.
Thank you very much, David. So far, I don't see any questions here. But remember, if you want to have any question, please leave it in the chat and we will make sure to answer it. The next speaker representing microbiomes for soy is Pedro Luis Castro. So please, Pedro, the floor is yours.
Okay, good morning, everyone. My name is Pedro, and I'm going to introduce you our project, Microbiome for Soy. This project explores how microbiomes influence food and feed system using soybean as a model crop. Please, next. Next slide. In my presentation is going to be fast. I put a lot of slides. The leader of the project is the Austrian Institute of Technology, and his head, Dr. Angela Sesic. And the project deals with the effect of soybean in the human gut and also in the fish gut, in order to develop novel fish feeds for aquaculture sector. Next slide. First of all, I'm going to present ourselves. Me and my co-workers. In my case, all of us, we work in the University of Las Palmas de Gran Canaria, in the Canary Island. And me working in cell biology area, histology in the medical school. And the co-workers, Maria Jesus and Rafael, works in the veterinary school. Maria Jesus in genetics, and Rafael, that is here in the present, is also with us, in animal production. Next, please. All of us belongs to the research institute named Aqua, and it have different research groups that deals with economic growth of the marine sector, conservation, diversity, support of coastal planning. And inside this institute, we have different research groups. One of them is the GAIA group, research group, the group of research in aquaculture, and we work focusing sustainable production, fish health, always under the fish welfare point of view. Yes, next, the different research groups. We are located in the east of the Gran Canaria island. Next, we are a big group of different profiles of researchers. Next slide, please. And my research groups, the research group in aquaculture have different facilities. One of them is this one of the right. The biggest one is named the whale because it has a shape of a fish, and the other one is close to the harbor. Next, please. The whale is where the animals are growth. Is named Aquaculture, and it have different sections: feed ingredients, testing units, warm water species, breeding station, marine biocides, pilot plant, and aquarium station. And I have to highlight that these facilities belongs to a transnational consortium, and research groups and also private companies can work with us with under very positive condition. Part of the wages will be paid by Europe. Next slide. Next slide, please. Okay, this is the wet part of the laboratory, and we have the normal laboratories to do proximal analyze genetics, histology, pathology, and tasting room. Next. And focusing in the project itself, the consortium involves 17 partners for 10 different countries. Next one. And we have from different countries, we have Bologna University, also Max Planck. Well, you have here most of them, Danone, different faculties around Europe. Next, please. The idea of the project is improving soybean crop productivity. Also, with this improvement, develop novel treatments that impact in human gut microbiome health. This part it will be done by Belfast University. And also, apart from human gut, also fish gut. Fish gut, how microbiomes are impacted with modification of the soil. Next, please. Okay. The idea of the project is, as you know, the main hypothesis is that replacement of marine ingredients can negatively affect growth performance and so on. Okay, next. We will try to understand how microbial fermentation of raw plants can improve the nutritional value. Next. We will integrate nutrition, microbiology, and intestinal physiology to improve or to work to deal with aquaculture diets. Next one. Our main objective is develop nutritional strategies based on fermented plant ingredients to improve or maintain productive performance. Next. And we will try to contribute to more sustainable aquaculture system, reducing the use of marine resources, and try to strengthen the scientific basis of aquaculture formulation. Next, please. The consortium will be divided in different work packages. There are some work packages focused in agronomy, of course, identification beneficial microbial consortia for soybean. There are different crops. We are testing different crops around Europe, in Hungary, in Italy, and different places. Another work package focus on nutrition, human nutrition and fish nutrition. We are involved in this group of work package. Of course, food technology, trying to develop new products with this improved soybean, and also as normal management and communication and so on. Next slide, please. Our my web package will be the fourth one, and it will deal with two fish species: salmon, that will be researched by our partner Mattis in Iceland, and we will work with sea bass. Okay, and we will have two different experience. One of them, we will try to understand how microbiome and fish health work with different presentation of fish soybean, concentrated, speller, isolated. This is the first part of the project. And then the second part, our partners from Mattis, we will fermentate it with thermostable bacteria from Iceland volcano. We will fermentate this new soy improve around Europe, and we will try to understand if this fermentation will improve the characteristics of the soybean. Next, please. We will try to understand how the new soybean will work in the digestive health, in the immune system, so technical parameters, biochemical, and also, of course, microbiome in the water and in the intestine of the, in our case, with sea bass. And the last one. Here you have our details to contact us in case you need further information. Thank you for your attention.
Thank you very much for the presentation. Now for the next presenter, we have Polypufa, which I believe is going to be presented by two of the partners, which are Oscar Monroy and Felipe Aguado Jimenez. Please, guys, the floor is yours.
So, good morning. Can you hear me?
Yes, loud and
Yes,
clear.
okay. Thank you. So, next slide, please. So, my name is Oscar Monroy. I'm a researcher at the Institute of Aquaculture, Torre de la Sal, which is one of the 120 institutes belonging to the National Research Council, CSAC. And I'm representing today Polypufa, which is a national project funded by the national funding body Agencia Estatal de Investigación. And this project has been running for 2 years and a half now, started in 2023, and still 1 year and a half to go. And along with ourselves in Torre de la Sal, there is another partner at the Spanish Institute of Oceanography in the north of Spain, in Cantabria, in Santander specifically. And I'm going to present today the overall objective of the project and also a bit of the work packages that belong to the sub-project, as we call it, that is led by ourselves in Torre de la Sal, and Felipe Aguado will be presenting his work packages later on. Okay, so the overall project aim is to clarify the mechanisms by which polychaetes synthesize endogenously omega-3 long-chain polyunsaturated fatty acids. These are essential compounds that are required by the industry. So we have uncovered that polychaetes are net producers of these compounds. And in this project, we are trying to develop strategies by which culture of polychaetes produce good quality biomass, and particularly with regards to omega-3 contents, okay? Next slide, please. So as I was saying, the project is structured in 4 different work packages, 2 led by IATS and 2 led by Spanish Oceanography Institute. So I'm going to be briefly going through the first 2 ones. Next slide, please. Thank you. So in this first work package, we are investigating fundamental mechanisms by which polychaetes synthesize omega-3 launching pupa, and we are using as a model species the polychaete Patinidales domerili. This is a very common model species used in evo vivo research. Multiple molecular processes have been, or methodologies have been developed over the years in these species, and among them we are taking advantage of gene deletion methodologies, CRISPR-Cas9 based deletion methodologies, in which we knock out genes involved in these pathways, in the pathways that enable animals to make omega-3s. I'm showing you these pathways on the right-hand side of the slide. And by knocking out these genes, elongases and desaturases involved in these pathways, we are trying to see which functions are lost in the resulting organism. No, we are developing this work package in collaboration with colleagues in University of Vienna, the group of Florian Reibel. And yeah, we are using these species for very fundamental research type of investigations, and we are also combining these very basic research type of studies with more applied investigations in the next work package. Please, next slide. In which we investigate whether freshwater adapted polychaetes, for instance, Namalicastis rhodocorder, which is a polychaete inhabiting these trees, these forest, rainforest environments like shown here. This is called Nipa palm forest. This is a picture taken in Malaysia, because we are developing this work package in collaboration with University Sains Malaysia, in particular with a group of Professor Alexander Chong Shu Chien. And as you can see from the picture on the left-hand side, this is a much bigger species of polychaete. It might be even longer than one meter. And we are trying to understand whether these species and other freshwater adapted polychaetes have higher capacity compared to marine counterparts to produce omega-3s, based on the assumption that because they don't have it in the ecosystems where they live, you might know that freshwater environments have less availability of omega-3 launching pupa compared to marine ecosystems, and we are trying to test whether polychaetes adapted to freshwater ecosystems might have enhanced capacity to produce endogenously these omega-3s compared to marine polychaetes. I hope I can show you some results in the next presentation, in the forthcoming webinar in a few weeks' time from now. Thank you. So Felipe, I think he will be continuing from this point onwards on work packages 3 and 4.
Okay, thank you, Oscar. Good morning, everybody. Okay, my name is Felipe Aguado from the Spanish Institute of Oceanography in Santander, in Spain. And now I'm going to introduce you the remaining work packages of Polypufa project. Both packages has a full technical approach. The first one, we will try to optimize the culture protocol of Eviste diversicolor by using agri-food byproducts and in order to know how this polychaete transform these wastes into high value unsaturated fatty acids. Then we have been trying with several agri-food byproducts. For example, brewer spent grain from the beer industry, We have also used wine lees from the wine industry, from red and rose wine. Also grape and apple pulp and skins from the wine and cider industries. We have tried also aquaculture sludge from rush system and biofloc wastes. We have tried these ingredients separately and evaluating the growth performance in order to formulate a specific diet for a diversicolor using this byproduct. Next slide, please. Once we have this specific diet for a diversicolor, then in the next work package we are going to intensify biomass production of a diversicolor using this specific feed in order to get a meal and to produce to use this meal as an additive or ingredient to feed marine fish, Charlie, sea bream or sea bass. And also we check the growth performance of this fish or of this fish on also fish welfare and health, and of course the fresh composition in order to know if there is a transfer of this polyunsaturated fatty acid that the worm is able to produce is transferred through the food channel to the fish, and finally if we can improve the flesh composition to get a more healthy product for humans. And that's all. Thank you.
Okay, thank you very much for that fine presentation. And up next, we have Project Act Fast, which is represented by, I believe it's Fabio Ugolini.
Yes.
It's been a change in the agenda because we had Alessio Bonaldo before, but now it's going to be Fabio. So Fabio, please go ahead. It's your moment.
Hello, everybody. Thank you for organizing this webinar. Can you move to the next slide, please? Act Fast is a project that recently started in June 2025. Is financed under the call Minimizing Climate Impact on Aquaculture Mitigation and Adaptation Solutions for Future Climate Regimes, which is a call that focuses on climate change and aquaculture. The project will last 4 years and received a 5 million budget. Next slide, please. So the European Commission recognizes the problem that climate change is creating for aquaculture in Europe, but global aquaculture in general. Most of you already are aware of it if you work in the sector. So we have an increase in heat waves, hypoxia phenomena, harmful algal blooms. There's more diseases in aquaculture productions, and feeds are not as effective anymore as they used to be. So those are problems that that are exacerbated by climate change. Next slides, please. So Act Fast has been developed with this challenge in mind. We want to create aquaculture systems that are climate resilient, data-driven, and low carbon. So just as some flashpoint, we want to demonstrate these systems in 4 different regions with different climate conditions in Europe. In each pilot site, we're going to run a full life cycle assessment to demonstrate the low carbon impact. The objectives is to essentially increase the health and productivity of different kinds of seafood in different aquaculture system, as well as developing a climate model that produces a 5 days forecasting and serves as an early warning system for aquaculture farmers in the event of climate events. We're also going to work on the ACFAS lighthouse, but I have a slide later about that. You can move to the next slides. So those are the 4 regions in which we're going to develop our pilots. We have Mediterranean coastal aquaculture systems, aquaculture system in the river deltas, Atlantic high energy systems, and inland waters inland waters in freshwater system. Next slide. So I'm going to focus a bit on the characteristic of each region. So the Mediterranean system, as I mentioned, those are coastal water. We're going to work with marine cage-based systems that we plan to enhance with IoT, AI, and essentially advanced sensing. The species that we're focusing on is the European sea bass. So there's an overlap on the research that is going to be done in the different areas, but each one has some defined characteristics. For example, in the Mediterranean zones, we're going to study prevalently the effect of heat wave on disease and how we can mitigate it, how we can formulate feeds that are efficient given the climate crisis, study the fish behavior, and develop short-term early warning systems. Next slide, please. In the river deltas, we are working prevalently on shellfish farming, and we are studying integrated multi-trophic aquaculture systems in inland marine environments. And the species that we focus on are mussel, clams, tilapia, mullets, oysters, and macroalgae as part of the IMTA systems. Here the research is focused more on the bivalves and their resistance to shifts in temperature, as well as the adaptation to seasonal changes that can be more extreme now in a climate change context. We're also looking at the effect of blue crab as an invasive species, for example, in Italy. I'm from Italy, and Alessio and Luca were also present at this meeting. I'm from Italy. We know that blue crab is a problem for the production of bivalves in northern Italy. Next slide, please. Inland waters, our study location are in Central and Eastern Europe. In this case, we focus on carp, catfish, rainbow trout, and duckweed. Duckweed as a part of freshwater IMTA that we're going to study in this pilot sites. And again here we're going to study adaptation strategies to climate change. This is a common denominator for all the regions that we're going to work with, as well as test some novel biosensor for the detection of toxins that are produced by harmful algal blooms. Next slide. In the Atlantic, here we focus on the production of salmon, and so we're working with marine caged farming system and land-based recirculation system for the rearing of salmon. Also here we're focusing on the development of functional feed that can improve the productivity and health of salmon in this system, as well correlating it with genetic and epigenetic biomarkers in the salmon. Next slide. So the project is going to produce some you're familiar with the term key exploitable results or key innovations. I mentioned we're going to work on a climate model that is going to function as an early warning system that provides at least a 5-day forecasting for extreme climate events. We're going to produce functional feeds that enhance the resistance of farmed species to potential disease and improve their performance and health, as well as feed formulation that are optimized for the adaptation of the fish metabolism to the new condition sets by higher temperature, for example, in summer related to climate change. We're going to develop some new integrated multi-trophic aquaculture farming systems that are combined intensive and extensives, as well as demonstrate some novel sensor for the analysis of the fish behavior, the detection of pathogen, and the monitoring of the toxin of the harmful algal bloom. This is an innovation action, so all these innovations are going to be between TRL 6 and 7 by the end of the project, which is demonstration in the relevant environment. Next slide, please. The ACFAS Lighthouse is going to be the platform that we're going to use to showcase all the project activities and the results. It is going to be a virtual space that is going to be accessible through our website at the end of the project, by the end of the project, and the platform is about showcasing the results, but also about offering capacity building initiatives for farmers throughout Europe that want, for example, to learn how to use our climate models or want to incorporate new farming practices in their setting. We want to use the platform not exclusively for ACPAS results. The idea is also to making it become an access point for resources in aquaculture farming in Europe, in connection to what to do with the prospect of climate change coming. So yeah, well, this is the per chart from the proposal. I was lazy, I just copy pasted it, but it just shows a little bit the project structure. The center of the project is work package 2, 3, 4, and 5, which are the pilots in the 4 regions. And around this core, then we develop all the necessary technologies and as well as perform our impact analysis. Next slide, please. So we have 28 partners for 12 different countries. Is a big mix of private enterprise and academia, as well as not-profit organization. I imagine I've seen most of the project, they have a similar consortium. So not much to add here. Next slides. And finally, those are our contacts. Our coordinator is the Alma Mater Studiorium of Bologna, represented by Professor Bonaldo, and I am the communication manager, Fabio Golini. Thank you very much for your attention.
Thank you very much, Fabio. That was a lovely presentation. And finally, I know we are a bit behind schedule, but bear with us just a bit more. We have representing EU Aqua Org, Luca Bergeloni, which is going to be presenting for them. So Luca, please go ahead.
Thanks. Good morning, everyone. I'm the coordinator of the euaqua.org, which is, as you can see, we'll try to integrate mainly genetic selection, so selective breeding, with other interventions to boost organic production for European aquaculture. So next slide, please. So why organic and why we need interventions to improve it and to boost its production? Because first, organic aquaculture has the potential to contribute to a better environment with greater biodiversity, less pollution in the sea or in the water in general, higher animal welfare, and also with a philosophy of market approach that is more sustainable, also on a social level. But as you can see from the figure on the bottom of the slide, still it's still a niche market, mainly salmon and blue mussel, with some sea bass and sea bream there. So the idea is to increase this percentage, and the approach is back in the next slide. So you see the objectives of euaqua.org are to increase the efficiency of organic aquaculture, mainly through genetic selection, to make organic aquaculture even more sustainable, so even more friendly to the environment. And finally, with completely different angle, is to increase consumer demand in general for aquaculture, but especially for organic aquaculture. This is something that is often overlooked, but it's very important that to translate somehow all the scientific results into greater penetration of aquaculture products into the market. Next one, please. So we have actually four different main work packages. The first one is mostly, if not exclusively, selection. So the idea is to move selective breeding in organic aquaculture and to reach the same high level of technology and efficiency as already obtained in genetic selection in conventional aquaculture. And we have different tasks. I won't go through them in detail. They're too technical, but essentially to improving the efficiency of selection, and also some organic aquaculture specific interventions like control reproduction without hormones, especially in sea bass, and produce all female populations without, again, using hormones, which are forbidden, of course, in organic aquaculture. So the key concept is to develop a panel of technologies that will improve selective breeding, still complying with the higher welfare standard of organic production. Next one. So the second one is probably the most related to BlueFeed cluster. It's essentially on feed efficiency. We have seen in previous slide that feed efficiency might become a problem, even greater problem in the climate change conditions. So the idea is first to select for more efficient fish using AI to measure when they feed individually, and so to select the fish that eat less and or grow more with the same amount of feed, and also to develop a cost-effective and sustainable organic diets. This is another major bottleneck for organic aquaculture, the cost and the environmental footprint of organic diets, which is greater than the one of conventional aquaculture, and therefore we are aiming to also solve, at least partially, this bottleneck. Next one. Also, we aim at a greater welfare and resilience with a very innovative switch from essentially selecting for fish that are resistant to disease to fish that are less infectious. So they transmit less the pathogens, which is also a shift in the approach. So no more individual resistant, but also more enlarged, broadened resistance of the sea cages, for instance, or the population, and also of the environment in itself. And also to develop early disease predictors to reduce fish suffering, so to increase fish welfare. And the last one, is again, as I mentioned, our understanding how consumers respond to especially labeling on aquaculture products, and you test their behavior using behavior economics and virtual reality settings to understand how they behave when they buy aquaculture products, and therefore try to design interventions to promote organic aquaculture on the market. And the last one, I think, is the consortium. You see, it's as we've seen in other projects, it's a fairly large consortium, not that large indeed. And we have very different expertise from selective reading, bioinformatics, machine learning and artificial intelligence, disease and welfare, fish reproduction, fish nutrition, market analysis, and so on. So it's I hope a very good mix of expertise that hopefully will deliver great success for organic aquaculture in Europe. And that's all for me.
Thank you very much, Luca. I think now it's the time for you guys to ask questions if you have some of them. I'm gonna check the chat here. I see one from Ola Oberg. It's for the last speaker. They are asking, how will you address the economic sustainability for organic aquaculture producers? So, Luca, if you can answer that one, please.
Yeah. Well, I think it was already somehow embedded in my presentation. Maybe it was too fast. The idea is to select for under the organic system, to select for faster growing, more resistant fish. The 4 species are actually, I haven't mentioned that, are rainbow trout, Atlantic salmon, sea bass, and sea bream. So the main farm species, fish farming species in Europe. So the idea is to, of course, it will not solve all the problems, but try to decrease the cost, increasing the efficiency, and also making the consumers more prone, more prepared to buy maybe higher cost, more expensive product from organic. And also the intervention that will be done in Work Package 2 is to increase the feed efficiency, which means less feed, but also more economically sustainable fish feed, which is actually the main cost item for organic production. I don't know if I answer your question.
Yeah. So yeah, thank you very much for the intervention, Luca. I hope that answered Ola's question. It says here a comment from Anna Speasons. It says, great presentations, amazing to hear about the project visions and work plans. Greetings from Aqua Phoenix, which is an EU-funded project working to capture and reuse aquaculture waste. So thank you very much, Anna. We will make sure to check it out and see if we can also do some work together. As for all of you that are here, it's been great to have you here in our webinar today. There's more information about each of the projects if you go into the NeoGiants LinkedIn page. We have posts about this session. We will also be uploading the full session on our YouTube channel, so please make sure to check it out in the upcoming days. And I think that would be it for all of us. Now, for one final thing that we can do is to please turn on our cameras. Oh, sorry, don't do it because I think you can't. But anyways, it's been a great space to have, and I hope that all of you enjoyed it. And we will see each other on the next one. Thank you very much.
Thank you.
Thank you. Thank you very much, Fernando. Goodbye.
Bye-bye.
Bye-bye.
See you. Bye-bye.